Okay, so our learning goal today states I can factor polynomials by using the greatest common factor, which is we typically call the GCF. Now in the homework that you did for today, in lesson 7.1, you were factoring the GCF out of what? Two numbers?
Well,
Sometimes, yeah. Sometimes you have to figure out the greatest common factor between two numbers, two constants. What else did you have to do? Find the GCF of what?
Two monomials.
Okay, a monomial or two monomials, yeah. So we were trying to find the GCF of monomial terms, basically, whether they were a constant or they were a variable. Variables were involved in them. So just as 6 can be factored to 6 times 1, or 3 times 2 times 1, so can other polynomials be factored. 6 is a polynomial, isn't it? What kind of a polynomial is 6? What would we classify it as? A constant monomial, yeah. So 6 is a polynomial. It can be factored. Well, so can other polynomials. Most polynomials can be factored, okay? So steps to factoring polynomials by the GCF. We're going to factor each term and find the GCF of those terms. So they're working together because they're all part of a polynomial. So we're going to find the GCF of all the terms of that polynomial. Then we're going to divide each of those terms by that GCF. We're going to divide out that GCF because that GCF becomes a factor. So the GCF is a factor. Let's underline that so that we make sure we do not, oftentimes what ends up happening when students are doing these is they forget about the GCF. And so the GCF becomes a factor, and the resulting terms after dividing becomes the other factor. So if you're factoring the GCF out of a monomial, your other factor is also going to be a monomial. If you're factoring the GCF out of a binomial, your one factor is going to be that GCF monomial, and the other factor is going to be a binomial factor because there were two terms in the other, two terms in the polynomial. So such as number 1, 9b cubed plus 5b. That is a binomial, right? So what should happen here is if we can GCF it, we should get a monomial GCF, and we should have a resulting binomial as the other factor. So can every polynomial be GCF'd? Were they all possible in your homework? I don't remember. Yes? Okay. So let me give you, and I'm not talking about when you just take it times 1. Having a factor of 6 times 1 is really kind of worthless, right? 6 times 1 doesn't get you anywhere. If you divide out that 1, you still have 6. So how about 3x? And can we think of anything that we could factor out of that we could take out of both parts of that, out of that monomial?
The x, since we don't.
The 3 could only be multiplied by 1, and the x could only be multiplied by 1, so it really wouldn't be very useful, right? How about if we were saying it with 3x and with 2? What if I had 3x plus 2? Could I have GCF that? Is there anything that I could divide out of 3x that I could also divide out of 2
No.
other than 1?
No.
No. So some polynomials cannot be, you can't find the GCF form. But we always have to look to see if we can find a GCF. So let's look at 9b cubed plus 5b. Let's first factor that. So give me the prime factorization for 9b cubed.
3 times 3.
3 times 3 are the prime factors of 9. And then we'll just write out all those factors of b. So times b, times b, times b. I want you doing this in your notes. The other term of our binomial is 5b. So we're going to say, what's the prime factorization of 5? 5, right? It doesn't, 5 is a prime number. And then we only have one factor of b in that term, don't we? So now, whichever factors they have in common, we'll multiply them together and say that's going to be our GCF. So what do they have in common? Just a B. Just a B. So we are going to go over and say our GCF is B. Circle that so you don't forget about it, because we don't want to forget about that. That's one of our factors when we factor this polynomial. So now what we do is we take each of those terms of the binomial. Well, that's not working very well. We take each of those terms of the binomial and divide it by that GCF. So what is 9b to the third power divided by b? 9b squared. There's nothing to divide the 9 by. Whoopsie, I guess it would be good if I had a pen instead of a... So 9b squared. One of those b's in the b to the third gets canceled out with the b that we're dividing by, so we end up with 9b squared. And then we're going to take our 5b, and we're going to divide that by the GCFB. What will we get? 5. And because there was addition between our two terms, there would be addition between these two terms. So because we had a binomial, 9b to the third plus 5b, after our resulting terms, after we divide out the GCF, has addition in it. Okay, now notice something about when you look back up at this list, notice something. We didn't circle that, we didn't circle that. What is 3 times 3 times b times b? What is that?
9b squared.
9b squared. What is, here we didn't circle the 5. And what did we get? Here, we were left with the 5, weren't we? So what wasn't part of the GCF is the resulting, so now our answer, let's put this right here, our final answer is, we have this, we could probably circle that right there too. We have our GCF, which is B, times, so we'll just show that with parentheses, 9b squared plus 5. We can say that we have factored it if we really could not divide anything else out of that binomial. In other words, do they have anything else in common? Did we do the best we could? So here's how you want to make sure that you have a good answer. You actually want to make sure that if you multiply this out, your factored name, this is just another name for the polynomial we started with. If you factor that, if you multiply that out, it should get you back to what we started with. If we actually multiplied our factored name back out, it had better get us back to where we started from. We better not have a different polynomial in the end, and we don't do it. So we started with 9b cubed plus 5b, and when we multiply it back out, we end up with our 9b cubed plus 5b. So again, our answer is the b times the 9b squared plus 5 in parentheses. That is the factored name for that polynomial. Questions? Okay, you go ahead and try the next one then. Try it first. Remember, in the first step, you factor each term. In the first step, you take 15a squared and you do prime factorization for the constant part. And you write how many factors of the variable there are. And then you decide what your GCF is. So what's the GCF for this one? 5. Okay. They have a 5 in common, but they also have an A in common, so our GCF is 5A. So maybe the safe thing to do is this. Start your answer so you don't forget about that. That's part of the factored name. We do not want to forget it. It's our monomial factor up front. And now we will find our binomial factor that will get multiplied by. So 15a squared is going to get divided by 5a. And 5a is going to get divided by 5a. So what's 15a squared divided by 5a? Basically, it's like this. What's 15 divided by 5? 3. And what's a squared divided by a? A. What's 5a divided by 5a? 1. Anything divided by itself is 1. What sign, what operation sign should be between those two terms?
Subtraction.
Subtraction. There's subtraction up here, so we need subtraction here. So we are going to say that we already wrote that one down. We now have this one, which is really 3a minus 1. So now that is going to become the other factor for our factored name. Again, you always want to look at the resulting factor, that 3a minus 1, and say, could I divide anything else out of that 3a that could also be divided out of 1, other than 1? Well, 1 can only really be, the only factors for 1 are what? 1, so we already know we can't divide anything else out, right? Okay, let's check. Let's check it out. 5a times 3a minus 1. This is a new name. We call this the factored name. In fact, let's put that in our notes so we understand that. This is the factored name. So that's how we would have gotten this problem back in chapter 6. We would have been given 5a times 3a minus 1, and we would have done distributive property to multiply it, right? So what we just did is we learned how to unmultiply. So 5a gets multiplied times the 3a, 5a gets multiplied times the 1, and that is 15a squared. Take away 5a. We get the same polynomial we started with. Okay, questions? So your answer better just be a new name for the polynomial you're factoring. Okay, let's go to the back then and try a trinomial. Think it's going to be any different? Oh, it's just that we're going to have to work with more terms, yeah, and we're going to have a GCF that's a monomial still, but we're going to have a 3-term factor that is going to be the other factor. So sometimes we'll just leave this subtraction as subtraction right here, and we'll just not worry about making that a negative 6x. So first thing we're going to do is we're going to say, what is 12h to the 4th factored out? What is 8h to the 2nd factored out? And what is 6h factored out? So prime factorization for the constant part. How many factors of the variable part do you have? What's the prime factorization for 12? 2 times 2 times 2 times 2?
No, 2 times 2 times 3.
Yeah, because 4 times 3 is 12, but 4 is not prime. But 2 times 2 is 4, and 2 is prime, so 2 times 2 times 3, that makes up our 12. And then we have h times h times h times h. 8h squared. What's the prime factors for 8?
2 times 2 times 2 times 2.
2 times 2 times 2 times 2? Or is it just 3 2's, right?
3 2.
And then 2 factors of h, okay? how about 6, what the prime factors for 6?
2 times 3.
2 times 3, and then we have that 1 factor of h. Okay. So now we start circling the ones that every list has. They all 3 have to have that factor. So they all have a 2?
And an H. Yeah.
And they all have an h, you say? Okay. Do they have anything else in common?
No.
All 3 of them.
No.
If one gets left out, can't be. So we're going to say the GCF for this one is 2H. Seems like it should be able to be more than that, doesn't it? That's as good as we're going to get. So we have our GCF is 2H. I might go right down here to the answer, and again, so that I don't forget about it, say I have a monomial factor, first of all, of 2H, and my other factor should be a what? Trinomial. We had a trinomial to start with, so our other factor better turn out to be a trinomial also. So we say 12h to the 4th divided by 2h. Well, here's the good news. If you have that list made of what 12h to the 4th is factored out, you should be able to just go look and see what is encircled. 2 times 3 is 6, and h. That would be h to the 3rd. So we have 6h to the 3rd. Or in other words, 12 divided by 2 is 6, isn't it? And h to the 4th divided by h is h to the 3rd. Okay, get the other terms divided by the GCF. Okay, what is 8h squared divided by 2h? 4h. What sign should go between those two? Addition, because the first sign in the trinomial is addition. Okay, what's 6h divided by 2h? 3. H?
No.
Okay, so remember what I said. If you go up to your list, the only thing not circled should be what you have. The only thing not circled is 3. Should there be addition or subtraction between 4h and 3? Subtraction. So we really have here 6h to the 3rd plus 4h minus 3. There's our other factor. A monomial times a trinomial. Again, look at that trinomial and say, is there anything you could divide out of 6, 4, and 3 other than 1? We're just making sure that we did a good job. 6, 4, and 3. Is there anything that can be divided out of there that's greater than 1? Anything? No. How about, do they all have h's? No, the last term does not have an h in that trinomial, so we know we can't take out any more h's. So again, you have to ask yourself that question. Did I factor it well? Did I have a good GCF, in other words? Sometimes we don't get a good GCF. We don't divide out enough. Okay, in this one I say, when the leading coefficient is negative, divide out a -1 first. Now, you don't have to do this, but this is how the book teaches it, so that's how we're going to just go through it, just so you can see it. But what you can do also is you can just make the GCF negative instead, okay? But I'm just going to go through it the way the book did it. So since the leading coefficient in this one is what? -5. We are going to divide, we're going to do what the book does, and we're going to divide a -1 out of there first. So we're going to say -1. So it's like kind of like we're dividing out here. In other words, if we put a -1 out front, the terms of that polynomial change to their opposites. So we would have a positive 5g cubed now, plus a negative 15g squared. I guess we could make that a minus, couldn't we? Let's do that, just to make life a little easier. Minus, okay? So we pull that -1 out. The terms of the polynomial change to their opposite. And now here's what we're going to do. We're going to go like this. So we don't forget it in the end. We're going to ignore it for a while, but we don't want to forget it in the end. So we're going to just work with this part right here. So we're gonna say we have 5g to the third, and we have 15g squared, and we're going to factor those. So we have 5 times g times g times g. We have 3 times 5 times g times g. So our GCF is what?
5G.
We got 5 in common,
G2.
G's in common. Oh, another set of G's in common. So it's going to be 5g to the second. It can be more than to the first power, our variable. Take out as many as we can. Okay, so now again, we don't want to forget about that. So that's kind of like we're not, that's going to come down also at some point. So now we're going to do step B, which says take each of those terms and divide them by that 5g squared. 15g squared divided by 5g squared. Okay, 5g cubed divided by 5g squared is? G. 5 divided by 5 is 1. We don't need that factor of 1 necessarily. G cubed divided by g squared leaves a g. What's 15g squared divided by 5g squared? 3, because 15 divided by 5 is 3. G squared divided by g squared is 1. We don't need that factor of 1. So we are going to put what sign between these two?
Subtract.
Yeah, remember we changed it up here. So this is subtraction now. So we're going to say this. I'm going to get that out of the way. This is going to become g minus 3. So for C, we need a -1. Remember, we took that out in the beginning. That's a factor. We need 5g squared. We need g minus 3. Now, chances are they would not leave that way in the answer bank, though. They would take this -1 times this 5g squared. So we would make it a negative 5g squared times g minus 3. That's going to be our answer, our factored name for our polynomial we started with. So do you see what maybe we could have done instead of dividing out a -1 in the beginning?
Just flip the opposite with the negative.
We could have said, since they both have 5s, we could have made this one, we could have made the 5 negative, and then our GCF would be a negative 5g squared, and then we would have been dividing by a negative 5g squared, and that would have changed, would have just changed how our division looked a little bit. Okay, so we don't have to factor out that -1, but for some students it's too hard to figure out the GCF without doing that. So you decide what works for you. Okay, in other words, let's do some quick multiplying in our head here. If we foiled this up, did distributive property, what would be -5g squared times g?
Negative 5G.
-5g to the third. Well, that's what it was. This is, if we change this to add the opposite, this would be a -3. What's a -5g squared times a -3? 15g squared, and it's a positive, isn't it? So we have a good factor name. Okay, think you can do this? Okay, here's the deal. You have to make sure that you don't fake this, that you fake you know what you're doing on this. Because tomorrow, what we do, if you were faking today, tomorrow is going to hurt. You are going to be like, feeling like you're in a class trying to learn the strangest foreign language ever. Okay, so you have to make sure you understand this today. So are you sure no one wants to ask me any questions? You think you got it? Okay.